If you're like me in that screen grab, you're probably tired of explaining exactly what that chance of rain means, which makes me kind of hesitant to use probabilities and percentages in a weather forecast. Not to mention, I've had plenty of consultants tell me that that's a bad idea. People just want to know yes or no, is it going to rain? Well, the social science research says it is a good idea. People just like knowing their odds. They may not exactly understand what an 80% chance of rain is, but they know that 80 is more than 20, and if they're making outdoor plans, they should probably do it on the day that says 20% chance of rain. The National Weather Service has kind of picked up on this latest social science research, and they're making, as you may have noticed, a very concerted effort to move more towards probabilistic forecasts and away from deterministic forecasts. So much so that in collaboration with UCAR, they've actually launched a number of training modules on the Comet MedEd website. You're probably familiar with the Comet program if you've ever had to renew your AMS or NWA certifications. One of these new modules is communicating probabilistic forecasts. Module's kind of cool. It contains 4 different scenarios: flash flooding, hurricane, winter storm, tornadoes, and offers the trainees the opportunity to select the most appropriate forecast and social media messaging in each case. And to assist in the selection of the most appropriate messaging, the trainees, the people that take the module, are provided with a table of best practices from the social science research. Living in Florida, of course, I'm going to focus on the hurricane portion of that training module. Here's a screen grab from the training module of what they basically describe as the status quo, kind of typical social media message. In this case, they use Hurricane Sally as an example. And here's an example of what the training module says you should do. I've highlighted in yellow kind of the key differences. Basically, you add phrases and numbers that tell you how confident you are in your forecast. In theory, this should work, but a lot of this is based on risk communication research in general. In other words, what is your risk of a terrorist attack, or a risk of catching a certain disease, or a risk of an earthquake, not necessarily a risk of a specific weather event like hurricanes. I had a chance to exchange a couple of emails with the chief of the National Weather Service Training Division about this, and he said, yeah, this is also new. They haven't had a chance to really test this. So I thought I would do exactly that. And I would wanted to know, does adding numerical probability information with words and phrases actually improve message comprehension and perceived message effectiveness? And does it depend on things like numeracy skills? In other words, a person's comfort with numbers in general, or with their mathematical skills. Does it depend on where the message is coming from, whether it's social media or TV? And does it depend on their experience with these sort of things? To test this, I created 3 mock Instagram posts for a hurricane named Judy. It's actually Hurricane Ian. I just changed the name to avoid confusion with the real storm. The first 2 are almost identical to the examples from the training module, except again, it's Hurricane Ian instead of Hurricane Sally. The third one is one that I created. As I was reading what they recommended in the training module, I thought, this isn't exactly how I would word it. So the third one is the version that I would write using my own words. In other words, for example, I changed things like high confidence to highly likely. I tried to make it a little bit more plain language. Plus, the social science research says that more research on the use of specific words and phrases is needed. So I thought I'll change things up a bit. And then I went into the studio and created 3 versions for television. To make it as much of an apples to apples comparison as possible, the wording was very similar as it was to the Instagram post. And this is important, the graphics were identical. In other words, I used only the cone graphic and that QPF graphic in both the Instagram posts and the video. We tested this out on UCF students because 1, the UCF campus was right in the path of our test case hurricane. 2, prior social science research says that college students would be an interesting population to study in this situation. And 3, because my own research has shown, and teasing ahead to the next segment, you're about to see for yourself in this research, college students are paying more attention to local TV meteorologists than you might think. So the students were randomly assigned to watch one of those videos or see one of those Instagram posts. In case you're curious, a total of 485 students responded to our survey. Of those, 450 were usable. Our survey group definitely skewed female, but they were actually a pretty diverse group and ranged in age from 18 to 59 years with an average of 23. And here's what you really want to know, the results. Hot off of the computer, not even published yet. As it turns out, adding numerical probability information did significantly improve perceived message comprehension on social media, but significantly reduced it on television. You can see the numbers there, but basically what we did is we asked them questions like, do you understand this message? Do you think you could paraphrase this message? Those that saw the plain language version that I created for Instagram were most likely to agree with that. Those that saw the plain language version that I created for TV were least likely to agree with that. Then we gave them a quiz to see if they actually understood what they just heard or read. We asked questions like, how strong is the hurricane expected to be? How much rain are we expecting? There were some differences. Things did slightly improve with the new and improved versions on social media, but the results were not statistically significant. And in case you're curious, overall, it was actually the plain old status quo TV message that people were most likely to answer correctly. Next up was a series of questions related to message effectiveness. Things like, I found this message effective. I found this message relevant to me. There were some differences, but the results were not statistically significant on social media. Television, though, was a different story. Interestingly, those that saw my plain language version that I recorded for TV were least likely to find that message effective. When you run the stats across all categories and all 6 conditions combined, you notice a clear preference for the new and improved social media posts. In other words, people liked the additional numerical information on Instagram. They found that to be significantly easier to understand and significantly more effective than the television counterparts, which is exactly the opposite of prior research that I've done and presented at an AMS conference before. My prior research shows that it's actually the broadcast meteorologist that makes things easier to understand and easier to comprehend than a social media post. So how do I explain it in this case? Well, remember, I use the exact same graphics on both Instagram and in the videos. And as I was recording the videos, I was kind of thinking to myself, I would never actually do this. I would never actually just stand up there and start spouting off a bunch of numbers without a graphic that spelled out the specific percentages and what it meant. In other words, I would have added a third graphic if I wasn't worried about making it an apples to apples comparison. And looking at the comments from the students that answered our survey, it seems that that was the problem. Those that saw the new plain language recommended social media said it was difficult to understand at first, but once I reread it, then I got it and I liked it. But if you're watching a video, you don't have the opportunity to go back and reread. Finally, we asked the students a bunch of questions related to general demographics, but also what they preferred in terms of weather information. Here's a stat that probably won't surprise you, but if you're a broadcast meteorologist, hang in there. I'm about to give you some good news. What is your primary source of weather information on a typical day? No surprise. Vast majority, 60%, said it was their default smartphone app. Here's the part that makes me happy as a recovering broadcast meteorologist. When the question changes to where would you go to get additional information about an impending hurricane, the numbers shift dramatically in favor of television, with an internet search being a close second. So if you're on TV and you're indexed high on Google search engine, you're in really good shape anytime there's a hurricane coming, because even college students are turning to you. Finally, we asked the students a bunch of questions related to their comfort with numbers in general. One of those questions was, when you hear a weather forecast, do you prefer predictions using percentages, like there will be a 20% chance of rain today, or predictions using only words, like there's a small chance of rain today? Overwhelmingly, the students preferred numbers. 44.2% said they wanted the percentages only, whereas 45.5% said they wanted some combination of words and numbers. Only 10% of the students said that they just wanted the words, no numbers. And by the way, I should mention that these were students in anthropology and communications classes, not weather or math classes. We also checked the results against the results overall. Those that were more comfortable with numbers in general found all messages, social media and the video forecasts, all of them, to be more effective and easier to understand. So I guess you do need to be comfortable with numbers to understand weather in general. My bottom line take-home point to you is this. Yes, people do seem to want to know their odds spelled out to them in a number. In other words, they want their risk quantified for them. But that number needs to be read to be understood. At least that's what it seems from this study. More research is definitely needed, though, on the visual side of this. I want to do a follow-up study where I do that video version with a separate graphic with the numbers actually spelled out. Stay tuned for that.